Now let me explain what we are seeing. 3i Atlas is reflecting sunlight. All objects in space do this, but the way it reflects light is unusual. The pattern is rare. It tells us something important about this object, about its properties, about what makes it different from most things we observe in space. I have spent over 40 years studying objects beyond Earth, asteroids, comets, meteors, distant planets. Each one reflects light in its own way. And over time, you learn to recognize patterns. You understand what is common, what is expected, and more importantly, you learn to recognize what is uncommon, what stands out, what deserves closer attention. The light pattern from 3i Atlas stands out. It is not what we typically see from natural objects. It is structured, regular, almost precise, and that raises important questions. Questions about composition, about surface properties, about the nature of this visitor from interstellar space. Let me start by explaining how we observe these objects. When an object passes through our solar system, we watch it with telescopes. We measure the light coming from it. That light is actually sunlight that has bounced off the object's surface. By studying this reflected light, we can learn many things: how bright the object is, how it changes over time, what it might be made of, how it is moving through space. Most objects show simple patterns. As they spin, different parts of their surface face the sun. Bright areas, dark areas, rough patches, smooth patches. This creates variations in brightness. The object gets brighter, then dimmer, then brighter again. It follows the rotation. It is predictable. We see this pattern constantly. It is normal, but 3i Atlas is different. The brightness changes are not simple. They are not just bright and dim as it rotates. There is structure to the pattern, a specific sequence, a rhythm that repeats, and this rhythm is what caught our attention. The first person to notice was an astronomer in Chile. She was reviewing data from her observatory, looking at brightness measurements collected over several nights. She saw the pattern immediately. It was obvious in the graphs: regular peaks, regular dips, too regular to be random, too structured to ignore. She contacted colleagues, asked them to look at their data to see if they saw the same thing. Within days, confirmations arrived. An observatory in Hawaii confirmed it. One in Australia saw it too. A space telescope added its observations. The pattern was real. It was consistent across all observations, multiple instruments, multiple locations, all seeing the same rare light pattern. Let me describe what we are seeing. The object goes through a cycle. It brightens in a specific way, then dims, then brightens again, but not smoothly, not gradually. The changes have steps, distinct phases, like stages in a process. First one level of brightness, then another, then a third, then back to the beginning. The cycle takes about 17 seconds to complete. 17 seconds from start to finish, then it repeats, over and over, hour after hour. The timing is consistent, not varying, not drifting, just the same pattern repeating endlessly. Within each cycle, there are 3 distinct brightness levels: a low level, a medium level, and a high level. The object spends about 5 seconds at each level, then transitions to the next. The transitions are relatively quick, not instant, but faster than we would expect from simple rotation. This 3-level pattern is rare, very rare. Most objects show 2 levels, bright and dim, or they show smooth variations, gradual changes as different surfaces catch the light. But distinct 3-level patterns are uncommon. They require specific conditions, specific geometries, specific surface properties. We tried to explain this with rotation. Perhaps the object has an unusual shape. Maybe it is triangular, or has 3 distinct faces. As it rotates, each face catches the sunlight differently. This could create 3 brightness levels. It is possible, but the timing creates problems. For an object to rotate every 17 seconds, it must be spinning fast, very fast. We can estimate the size of 3i Atlas from other measurements. It is probably around half a mile across. An object that size, spinning every 17 seconds, would experience significant stress. The surface would be under tremendous force. It would tend to break apart, to fly into pieces. Natural objects can spin this fast, but it is uncommon, and they usually show signs of instability: wobbling, irregular rotation, pieces breaking off. We see none of this with 3i Atlas. The pattern is stable, unchanging, perfectly regular. We also looked at the light curve more carefully, the graph showing brightness over time. The shape of this graph tells us about the nature of the changes. Smooth curves suggest gradual transitions, sharp angles suggest abrupt changes. The curve from 3i Atlas shows sharp transitions, quick jumps between brightness levels. This is unusual for rotating objects. Another possibility is surface patches. Maybe the surface has three distinct areas, each with different reflective properties. One area is dark, one is medium, one is bright. As the object rotates, we see each area in turn. This could create the three-level pattern, but it requires very specific conditions. The patches would need to be precisely arranged, evenly spaced around the object, each taking up roughly the same amount of surface area, and the boundaries between patches would need to be sharp. Clear divisions, not gradual transitions. This is possible, but nature rarely creates such precise arrangements. We considered composition. Different materials reflect light differently. Rock is generally dark, ice is bright, metal can be very reflective. Could 3i Atlas have patches of different materials? Patches arranged in a specific pattern, creating the three-level brightness we observe? This is one explanation, but it raises questions. How would such patches form? What process creates distinct regions of different materials? On asteroids, we sometimes see variations, areas where impacts exposed fresh material, regions where ice collected in shadowed craters. But these variations are usually subtle, gradual, not the sharp distinctions we are seeing here. The spectrum provides more information, the colors of the reflected light. By analyzing the spectrum, we can identify materials. Each substance has a characteristic spectrum, a fingerprint. Rock shows certain features. Ice shows others. Metal shows different patterns. The spectrum of 3i Atlas is being studied carefully. Initial results are interesting. The spectrum shows features we do not immediately recognize. Some absorption lines that do not match common materials. Some reflection characteristics that are unusual. This suggests the composition might be exotic, materials we do not commonly encounter, or mixtures we have not seen before. One team suggested the object might have a coating, a layer of material covering the surface. This coating could have formed during the object's journey through interstellar space, exposed to radiation, to cosmic rays, to particles and dust between stars. Over millions of years, a coating could build up, change the surface properties, create unusual reflection patterns. This is an interesting idea. We know that surfaces in space change over time. Radiation damages materials, creates new compounds, alters structures. The surfaces of asteroids and comets show evidence of this. They are weathered, modified by exposure to space. An interstellar object would have experienced far more exposure, far longer weathering. The effects could be significant. Another team looked at magnetic fields. Some objects in space have magnetic properties. These fields can trap particles, create regions of charged material around the object. Could these particles affect how light is reflected? Could they create patterns in the brightness? It is possible, but we have not detected a magnetic field around 3i Atlas. That does not mean it is absent, just that we have not found it yet. We also considered the possibility of outgassing. When comets approach the sun, ice on their surface heats up, it turns to gas. This gas can create clouds around the object. These clouds reflect light. They can create complex patterns. Could 3i Atlas be outgassing in a specific way, creating the three-level pattern we observe? The problem is that we see no direct evidence of gas, no coma, no tail, no spectral features that indicate gas molecules. The object appears to be relatively inert, not actively releasing material, so outgassing seems unlikely, but we cannot rule it out completely. Perhaps the outgassing is very subtle, too faint for our instruments to detect directly, but strong enough to affect the light reflection. There is another explanation, one that is more speculative. The pattern might not be natural. It might be artificial, created by design rather than by chance. This is not a claim I make lightly, but it is a possibility we must consider. Because the pattern is so unusual, so rare, so precisely structured. If the pattern is artificial, it could indicate technology, something designed to reflect light in a specific way. Perhaps for communication, perhaps for identification, perhaps for reasons we do not understand. This is highly speculative. I want to be clear about that. We have no proof, no confirmation, just an unusual pattern that does not fit easily into natural categories. The idea of artificial objects in space is not absurd. We have sent many probes ourselves. Voyager spacecraft, Pioneer probes, New Horizons, all traveling through interstellar space now. All artificial objects, all reflecting sunlight in patterns determined by their design. If we can create such objects, other civilizations might do the same. The challenge is proving it. Showing that something is artificial requires strong evidence. A pattern alone is not enough. We need additional signatures. Radio signals perhaps, unusual trajectories, anomalous behavior, something that cannot be explained naturally. We are looking for these things. But so far, we have only the rare light pattern. I spoke with several colleagues about this, scientists I have known for decades, people whose judgment I trust. The consensus is caution. The pattern is unusual, it deserves study, but we should not jump to conclusions. We should test natural explanations thoroughly. Only if all natural explanations fail should we consider artificial origins. That is the scientific method. Start with the most likely explanations, the conventional ones. Test them carefully. If they do not work, move to less likely explanations. Keep going until you find something that fits, or until you exhaust all reasonable possibilities. Only then do you consider extraordinary explanations. We are still in the early stages of this process, testing conventional ideas, gathering more data, looking for additional clues. The observations continue. Every clear night, telescopes track 3I Atlas. They record the light pattern, the spectrum. Any changes or variations, we are building a complete dataset, a thorough record. The object is getting farther away now, more distant, fainter. Each week it becomes harder to observe. Soon it will be too faint, even for large telescopes. When that happens, observations will stop, the object will fade into darkness, and we will be left with the data we have collected, the questions we have raised. That is why this time is important. Every observation adds information, every measurement helps. We cannot let this opportunity pass. Because once the object is gone, it is gone forever. It will travel through space for thousands of years, maybe millions, before encountering another star system, another place where it might be studied. This is our chance, our window, and we must use it well. I find this situation fascinating, not frustrating, not disappointing, fascinating, because it shows us that space still holds surprises, still presents mysteries. We do not know everything. We do not understand everything, and that is good. That means there is more to learn, more to discover, more to explore. Every interstellar object teaches us something new. Oumuamua taught us that such objects can be strangely shaped, fast-moving, with unexpected behaviors. Comet Borisov showed us that some are more familiar, more typical, and now 3I Atlas is showing us rare light patterns, complex reflection behaviors. Each visitor expands our knowledge, challenges our assumptions, pushes us to think more carefully. The universe is vast, full of variety, full of possibilities. We see only a tiny fraction of what exists, the objects near us, the ones that happen to pass close enough to observe. Each one is a messenger, carrying information from distant regions, from places we cannot easily visit, from environments different from our own. Some of these messengers tell simple stories. They are rocks, ice balls, debris from planetary formation. They follow expected patterns, show familiar properties. They confirm what we already know, but others tell stranger stories. They show unusual properties, unexpected behaviors, rare patterns. They challenge us, push us to think harder, to question assumptions, to expand theories. 3I Atlas is one of these challenging messengers. It presents a puzzle, a rare light pattern that does not fit neatly into our categories. Our job now is to solve this puzzle, to understand what creates this pattern, to learn what it tells us about this object, and perhaps what it tells us about interstellar space more broadly. The work continues, observations proceed, analysis deepens, different teams approach the problem from different angles. Some focus on rotation models, others on composition, still others on exotic explanations. All contribute, all add pieces to the puzzle. Eventually, a picture will emerge. an understanding will develop. We will know what causes the rare light pattern. That understanding might be simple, a combination of rotation and surface properties we did not initially consider, or it might be profound, something that changes how we think about interstellar objects, about space between stars, about the diversity of objects in the galaxy. Either way, the effort is worthwhile, the investigation is justified. I encourage you to follow this developing story, to stay informed, to ask questions, because your interest matters. It supports the work. It reminds people why space exploration is important, why studying distant objects has value. Every person who cares about these discoveries helps make future discoveries possible. If you found this discussion valuable, please share it, talk about it with others, help spread awareness. Science benefits from public engagement, from people paying attention, from support for the research. Your engagement makes a difference, your interest contributes. And again, if you wish to support this channel directly, please consider becoming a member. The join button is below this video. Your support helps me continue bringing you these detailed scientific discussions. Every contribution, large or small, helps sustain this work. Subscribe if you want updates on this story. As we learn more about the rare light pattern, I will share that information here. I will explain new findings, discuss new theories, present new data. This is an ongoing investigation, new information arrives regularly, and I will keep you informed as it develops. Remember that space is full of mysteries, full of things we are still learning to understand. Objects like 3I Atlas remind us of this. They show us how much remains unknown, how much work remains, how many questions wait to be answered. And that is not a problem, that is an opportunity. A chance to expand knowledge, to push boundaries, to discover new things. The rare light pattern is one aspect of a larger mystery. What are interstellar objects? Where do they come from? How do they form? What properties do they have? What can they teach us about the galaxy? These questions drive our research, motivate our observations, justify our efforts. In my 4 decades of studying space, I have learned to appreciate mysteries, to value questions as much as answers. Because questions drive progress. They push us forward. They force us to look more carefully, think more deeply, work more thoroughly. And in that process we learn, we grow, we advance. 3I Atlas poses questions, important questions, about light reflection, about surface properties, about the nature of objects from beyond our solar system. These questions will be answered through careful observation, through detailed analysis, through patient scientific work. The answers will come. They always do. We just need to give it time. Thank you for listening. Thank you for your interest in this topic. Your attention to these scientific investigations helps support the broader enterprise of space exploration, helps ensure that we continue looking outward, continue asking questions, continue seeking understanding. That is important work, essential work, and your engagement with it matters. Keep looking up, keep wondering, keep asking questions about the universe around us, because that universe is full of wonders, full of things waiting to be discovered. And every now and then, something passes close enough for us to see, close enough to study, close enough to learn from. When that happens, we have an opportunity, a chance to expand our knowledge. And we should take it. That is what we are doing with 3I Atlas. And that is what we will continue doing, until the very last observation, until next time.